Here we have 3.5, factoring by grouping. Our essential question, how do you factor by grouping? Now, factoring by grouping is nice because we use it when a polynomial has 4 terms, as the definition says right here. So when a polynomial has 4 terms, that's the key goal. And when it has 4 terms, we can make 2 groups and factor out the GCF from each group. So let's kind of underline that. We're going to make 2 groups. That's step 1. Then we're going to factor out the GCF from each group. That's step 2. And then we're going to have a third step. And step 3 is actually example 1. So this is our step 3. So for example 1, they've already formed the 2 groups and factored out the GCF from each group. So let's look at what we're going to do for our third step. For our third step, I'm going to look at each one of these pieces. And I notice that both of them have x minus 2. So we're going to write the x minus 2 because both of the pink pieces have x minus 2. We're going to factor out the x minus 2. And then we're going to write what's left over. What's left over? We have an x plus 3. If you want, you can think of that as this was our common binomial. And these were our original GCFs. So these were the GCFs from step 2. And that's the step that was already done from us, this step right here. If we look at this next piece, look at this example on our right. I notice that we have little pieces here, 2 separate pieces. Now this is a negative. What number is here? This is a negative 1. I look at my binomial in the middle and I ask myself, are they the same? The answer is no, but I can make them the same. I can make them the same by factoring out a negative 1. And if I take out a negative, this right here becomes a positive. So I'm going to rewrite this. Now I'm factoring out a negative, and that'll make this positive, and that switches the signs here. So we changed to a positive to switch signs. Now we have the same binomial. So we put the common one. And then what pieces do I have left? I have 4x squared plus 1. And check, can I factor either of those pieces again? No, I cannot. Let's look at our next piece. Okay. I have an x plus 2 and an x plus 2. Are those the same? Well, this is 2 plus x, but can I rearrange that to x plus 2? The answer is yes. Could I have rearranged this one right here? No. If I rearrange this one, this would be a negative x to the third, and I wanted it to be a positive x to the third, so I had to change those signs. So now I'm looking, I have the x plus 2 as my common binomial, that's the one in common. And what were my GCFs? I had a 5 minus x. So now we're going to do the whole process. Step 1, 2, and 3. So from our directions, step 1, we make 2 groups. Two groups. Step 2, if you look back to what we underlined for step 2, factor out the GCF from each group. So we look at the first group. Looking at the first group, I see I have a 6b to the third, 8b squared. My GCF is going to be 2b squared. This is going to be 3b plus 4. 2 times 3 gives me 6. B squared times b gives me b to the third. 2 times 4 is 8. B squared times no b's is b squared. Then we have our plus. What is our GCFs here? Our GCF here is 3. 3 times 3b, that gives me 9b. 3 times positive 4, that gives me positive 12. Okay, so that was step 2. Step 3, we have our common binomial and then our GCFs. Well, our common binomial is 3b plus 4. What were our GCFs? 2b squared plus 3. Let's check. Can I keep factoring either one of those? No, I cannot. So, step 1, make 2 groups. Step 2, factor out GCF from each group. Step 3, we write it as the common binomial. I'm going to have to write that a little lower. Times, I have my GCF plus my GCF. Again, these here were my GCFs. All right, let's try our next example. Sometimes we have to look and we might have a GCF straight from the beginning. So if I look here, I notice that I have a y at the end. So I have a y in each term. So here our first step is going to be factor out our total GCF. So I can factor out that y. And then I get 5y to the third minus 15y squared plus y minus 3. Now this y is just going to kind of stay on the outside and keep coming with us. I notice in the middle I have 4 terms. So I'm going to make my 2 groups, factor out the GCF from each group, and do my common binomial GCF. So let's make our 2 groups. We have this y still on the outside. I'm looking at this first group. My GCF 5 and 15, that's going to be a 5. Y squared. I'm going to have 5y squared. That's going to be, I need 1y. Y squared times y is y to the third. 5 times 1 is 5. 5 times negative 3. And then the y squareds are good. Plus, do I have a GCF here? Not technically, so that means I have a 1. Okay, so again, I have the y just out here. Let's do our last step. We have common binomial, GCF plus GCF. What one's in common? Y minus 3. And then I have 5y squared, and then plus 1. Those were my GCFs from step. That is my answer. Again, check. Can I factor either of those again? No, I cannot. Go ahead and try the third one. Always remember to look to see if we have a GCF overall, like I had the Y. I notice I'm ending in an X again, but I notice 18 doesn't have an X. So let's go ahead and rearrange this so that we are in standard form. And once we've put it into standard form, you can go through your 3 steps. All right, so let's make the 2 groups. Now, whenever I have a minus here, we're going to put the minus with the 3 and put a plus in between them. So we made our 2 groups. Now let's factor out the GCF from each group. Here, 2 and 12, my GCF is 2. And then I have x squared times, I'm going to need an x minus 2 times 6. And then x squared and x squared, so I don't need any x's there. I look here, what's my GCF here? 3 and 18, my GCF is going to be 3. But if I take out a 3, I'm going to have a negative x and a positive 6. I know I'm going to need to I want a positive for my first term, but I have a negative. So what I'm going to do is take out 3. Negative 3 times positive x gives me a negative 3x. Negative 3 times negative 6 gives me a positive 18. So in order to get these to be the same, I factored out a negative 3. So if this is negative, factor out a negative. Okay, last step. Let's write our common binomial. What's our common binomial? X minus 6. What were our GCFs? 2x squared minus 3. Again, can I factor these anymore? No, so we are done. Let's go ahead and look at example 4. we're going to factor and sketch, and then label the x and y intercepts. All right, so I'm looking at my polynomial. First thing you do, is there a GCF overall? I notice they're all divisible by 2. Okay, now I notice there's 4 terms, so we're going to group. We keep the 2 on the outside. Oh, there's a minus with this x, so pull it with the x and put a plus sign in the middle. Step 1 is to group. Step 2, what's my GCF here? X squared. That gives me an x minus 5. X squared times x is x to the third. X squared times negative 5x squared. I notice that this term has a negative. What did we note here? If that's negative, factor out a negative. And the reason why is we want this to be positive and this to be negative, so it matches what I have in orange here. So I'm going to factor out a negative. What's my GCF of x and 5? There's no number, so it's going to be a 1. And then I have negative 1 times x is negative x, negative 1 times negative 5. All right, again, we just keep this 2 on the outside. What was our common binomial? X minus 5. And then I have my GCF. So now I check, am I completely done factoring? I notice this is a difference of squares, so I can keep going here. So I get a 2, an x minus 5, an x plus 1, an x minus 1. So this is f of x. Let's sketch it. In order to sketch, I need my end behavior. My leading coefficient is 2. My degree. We can look in 2 places. We can look at our original problem, that's x to the third, or here I notice I have x to the first, x to the first, x to the first, and they all have 1s. So that's going to be a 3. So this is going to be a down, up. We're positive, odd. I also need my x-intercepts. X-intercepts, we make f of x equal to 0. So I'm going to have 0 equals x minus 5, x plus 1, x minus 1. Oh, there's a 2 in front there. So we set all of these equal to 0. X minus 5 equals 0, x plus 1 equals 0, x minus 1 equals 0. I get x equals 5, x equals negative 1, x equals positive 1. Let's write them out. 5, 0, negative 1, 0, 1, 0. I need one last thing in order to graph it. We did the x-intercepts. We also need the y-intercept. How do we find the y-intercept? We set x equal to 0. So here, 2 times 0 minus 5 times 0 plus 1 times 0 minus 1. 2 times negative 5 times 1 times negative 1. I get negative 10, positive 10. And that's going to give us 0, 10. Let's graph all of this lovely information. Let's do our x-intercepts. I notice they all have multiplicity of 1. So I put 1 at 5, negative 1, 1. My y-intercept is at, let's label them. My y-intercept is at 10. And I'm low, high. So we're going to connect like that. Let's do 2 more examples with the grouping. We're going to factor and then sketch. First thing we always look for, overall GCF. I notice all of these numbers are divisible by 3. Now, for terms, so we're going to group. I'm going to go ahead and give you some time. Go ahead and pause the video so that way they can have some time to try and do the rest by themselves. I want them to continue factoring and then sketch out the x and y intercepts. Now that you've had time, let's go ahead and do it. I have my GCF on the overall GCF on the outside. We're going to group the first two. The minus goes with the 9. Put a plus in the middle. See, my GCF here is x squared, x plus 3. Since this is negative, our GCF is going to be negative. 9 and 27, that's going to be a 9. Negative 9 times x. Negative 9 times positive 3 gives me negative 27. My common binomial, x plus 3. My GCFs were x squared, negative 9. I notice that this is a difference of squares, so I can keep going. Now, we factored it completely, but I might not want to write it out like this. I see that I have an x plus 3 and an x plus 3. So I want to write it out where I have my x plus 3 squared, so that I know the root here is a multiplicity of 2, or that the 0 here is a multiplicity of 2. So that's us factoring it. Now let's find our x-intercept. So for our x-intercepts, y equals 0. I set this piece equal to 0, and this one equal to 0. And since our multiplicity is 2, we're going to have a bounced here. So I get x equals 3, x equals negative 3. I have 3 comma 0 and negative 3 comma 0. Now we're going to find our y-intercepts. For our y-intercepts, I make x is 0, so y equals 3 times 0 minus 3, 0 plus 3 squared. Equals 3, that's negative 3, that's 3 squared. 3 times negative 3 is negative 9, times that's 9, so I get negative 81. Go ahead and graph this, sketch this graph. Our end behavior, leading coefficient is 3. Degree, we can look here, where I have 1, but I have 2 of those, so I have 3. So this is going to be down, up. My x-intercepts are at 3, the negative 3, but at negative 3 we have a bounce. Our y-intercept is negative 81. And we're going to go down, up. So we're starting down. We need to make sure to bounce. And then we go up. For this example, we have f minus g. Now, whenever we have this, we need to make sure to distribute the negative to all of g. So, for f minus g, we're going to have x to the third minus 3x squared. That's my f. Minus my g is 4x minus 12. So again, we need to make sure that we distribute that negative. Minus 4x plus 12. We need a factor, sketch, label all the x, y intercepts. Let's go ahead and do our grouping. Group the first two, put a plus in the middle, group the next two. Our GCF here is x squared. I have an x minus 3. Remember, when we have that negative here, our GCF is going to be negative. 4 and 12, that's going to be 4. Negative 4 times positive x, negative 4 minus 3. Now notice these are the same, so we're good. Take out our common binomial. What were our GCFs? X squared and negative 4. Can I keep going? Yes, we have a difference of squares. I have x minus 3 minus 2, x plus 2. So this is what y equals. X-intercepts, make y 0. So I get an intercept here, here, here. So I have an intercept at 3, 0, 2, 0, negative 2, 0. Next, we have our y-intercepts. Y-intercept, we make x 0. I get negative 3, negative 2, 2. That's going to give me positive 12. So this is at 0, 12. In behavior, my leading coefficient, let's look at here, that's a 1. My degree is, I have x to the first, x to the first, x to the first. All of those are 1, so 1 plus 1 plus 1 is 3. Or we can look up at the beginning, that's 3. So we're going to be down, up. Graphing all of this, I'm going to graph all of my x-intercepts. We had 1 at 3, 2, negative 3, y-intercept at 12. We are down, up. And there we go. Let's make this a little better.